All right, welcome. Let's work Algebra 2 homework 7.4. And so you're going to need a graphing calculator for this one. And the first few problems are just like, okay, let's graph this function and find all this stuff like x-intercepts, maxima, minima, intervals of increase and decrease, number of turning points. Okay, number of turning points, we might call those relative extrema, local maxima, local minima. Okay, let me see if I can find a place to put this that's not in the glare of the light above me. Okay, that will work. So, okay, it's validating my OS. Okay, that's calculus, we don't need that. That is also looking like possible calculus. Let's type in negative x to the 4th power plus 3x into y1. And we're going to zoom to the standard window, always to start. And then if we need to like zoom in or something or adjust the window as needed, we can do that after the fact. Okay, so my x-intercepts are going to be x equals 0. I can see that. Okay, I can tell that when I plug in x equals 0, that'll be a 0. I don't really need to locate that one, but I've got one between 1 and 2, and I don't think it's worth like guessing 1.5 or anything. I'm going to calculate a 0. I can see it's between x equals 1 and x equals 2, so I'm going to type in my left bound of 1, my right bound of 2. Give it a guess. Well, I mean, you can go over there and be like, okay, it's right there. And then it'll give us our approximate 0. Now in this class, we're going to round to 3 decimal places. So that's 1.442. You could round, you can just copy the first 3 as whatever you like. Okay, local maxima. Okay, I'm seeing one right here, right up at the top. I don't think there's going to be any local minima because it looks like this thing kind of like does a little bit of bending and then turns back down. So we're going to calculate a maximum. Okay, we're going to go to the left and the right of it. It looks like it's between 0 and 2 for sure. So I'm going to type in a left bound of 0 and a right bound of 2. Doesn't really matter what the guess is. And then it will get me the location of a relative maximum. And I think we're going to copy both coordinates, 0.908 or 0.909, and y is 2.044. Okay. Local minima, there were none. Intervals of increase, well, that was all the way up until the maximum. So that's just going to be when x is less than 0.909, and decreasing, it came down after that maximum, so that would be when x is greater than 0.909. And total number of turning points, there was just one. Okay, there's that one local maximum. Okay, let's go on to the second one. Type this one in, 1/2 x to the 3, minus 2x plus 5/2. Okay, we're going to zoom to the standard window. Okay, that looks pretty good. All right, so the zeros, there's only going to be one of them. I'm going to calculate a 0. It'll be between, and okay, I typed in the numbers on the last one, but I'll just show you can scroll to the left of the 0 and to the right of the 0 and pin it in like that if you want. Doesn't matter, either way. And that's going to be x equals negative 2.457 or negative 2.456. It's the next one, local maximum. Okay, so there's going to be a maximum somewhere, around here. So we're kind of just trapping it in there. It's between those two arrows. You don't really need a guess for maximum because we're trapping it in so there's only one maximum. So the guess doesn't matter so much. And so that would be negative 1.155 and 4.039 or 4.040. That's the coordinate of my local maximum. Local minimum happening down here where the function goes from decreasing to increasing. Okay, and I found that to be at x equals 1.15 something. And y is 0.960. So 1.155 and 0.960. Intervals of increase. Well, it's increasing in this first point up until that location of the relative maximum. So that would be negative infinity up to negative 1.155. But then also after the location of the relative minimum. Okay, so after this 1.555. Okay, I think, let me make sure I did that right. I feel like I just moved the cursor a little bit, but yeah, okay, yeah. And 1.555 up to positive infinity. You know, if you wanted to make these open intervals where these are parentheses, it'd be the exact same thing. All right, and then interval of decrease would be between the relative maximum and the relative minimum, so that would be negative 1.5155. So similar numbers, 1.555. Okay. And then number of turning points was 2 because I had 2 extrema. Right. Number 3, x to the 4 minus 3x to the 2 plus x. Right. X to the 4 minus 3x squared plus x. Oh, okay, let's just try that again. X to the 4 minus 3x squared plus x. Right. And, okay, yeah, we're going to zoom to the standard window, hope for the best. Okay, I hope we get one where we have to adjust the window. Definitely did that for the quiz. You're going to have to adjust the window on the quiz and I think the test as well. Okay, but the x-intercepts, I can see that there's one at x equals 0, then that makes sense based on the formula. I'm going to calculate the 0 over here. It looks like it's at about -2, so it's between -3 and -1. Okay, oh, whoops. No, it's supposed to be -1. We're going to have to start that over. -3, no. Pardon me. -3 to -1. Yeah, there we go. X equals -1.879. Okay, we saw x equals 0, and then there's going to be another one over here between 1 and 2. So my left bound is 1, my right bound is 2. Give it a guess, that's 1.532. 532. Right. The local maximum, that's going to be at x equals 0 and y equals 0. I can just tell, I can see that it's hitting the origin. So I don't even need to use the calculator for that. I'll save you some time. The local minimum spots, those are things we're going to need to use the calculator for. So I'll go over here, kind of scroll to the left of it, scroll to the right of it, give it a guess, and I get -1.301. And then the y-coordinate there was -3.514. Okay, intervals of increase. Well, okay, from this -1.301 back to 0, okay, it's got a positive slope. And then also when x is bigger than that second local minimum, which I never actually computed. Okay, so I'm going to need to find that minimum over here. Okay, we got it pinned in there. 1.131. And -1.070. But then there's, okay, another interval of increase is going to be, I don't know if you can see that, where I increase beyond 1.131. So I'll just say x is greater than 1.131. Okay, so those are my intervals of increase. My intervals of decrease will be when x is less than this, right, when it's coming down here. So that's x less than. You could even make these less than or equal to, or greater than or equal to if you want it, doesn't matter. X is less than or equal to -1.301, or the other interval of decrease is between 0 and the second local minimum. So I'd say 0 up to 1.131. And in this case, there were 3 turning points because there were a total of 3 relative extrema. And the last one, at least of these four, is going to be x to the 5 minus 4x to the 3 plus x to the 2 plus 2. Okay, yeah, this one looks like I'm going to have to adjust the window a little bit. I think that the actual maximum is happening above 10, so I'm going to change that window. I'm going to look at 10, and I'm just going to make that 15. And then there we go. We're seeing everything we need to see. Okay, and I'm going to calculate the zeros. Okay, there's one. X equals 1, y equals 0. Okay, there's going to be another one over here at x equals 1.747. And then there was one over here where x was negative, so I'm going to calculate a 0. Looks like it's at about -2, so I'd say -3 to -2. Okay, that worked. Had it not actually been between -3 and -2, had the line actually crossed on the other side of -2, it would have kicked you an error and said like, hey, I couldn't find a 0 in there. And then you would have said from -3 to -1, and you would have found it. Hey, I got lucky. I intended to do -3 to -1, I just typed it wrong. So x equals -2.159. Okay, those are my zeros. Okay, there's a maximum right here, so I'm going to calculate a maximum. Okay, that's to the left of the maximum. Okay, that's to the right of it. And then I get -1.626. Or -1.627. And also 10.474. What else? Okay, that's the maximum. Minimum is going to be at 1.458 and -1.683. Okay, intervals of increase would be all the way from -infinity up to the relative maximum. So where x is less than -1.2627, and where x is greater than the relative minimum, it resumes increasing, and the relative minimum happened at 1.458. Decreasing between the two extrema, so that would be between -1.627 and 1.458. And then the number of turning points is the number of extrema. I had one maximum and one minimum, so it's a total of 2 turning points. All right. It starts to speed up a little bit. Okay, x-coordinate of the point at which this function has a relative maximum. Sure. So this is one of those, we could draw the sketch of this graph, but we probably wouldn't be able to determine the location of the relative maximum. Yeah, okay, third degree negative leading coefficient goes down, up, down. Where it switches from up to down, we don't really have the tools to determine that, but I guess now we do, we're using technology. So I'm going to say, all right, -1/3. I might recommend you use the fraction bar, which remember we access the fraction bar by hitting the green button to get to F1, and then just pressing enter. Okay, so -1/3 times x plus 2, x minus 2 times x minus 6. Okay, we're going to graph that on the standard window. All right, and we're going to find the location of the relative maximum. Okay, so I would say, all right, we are definitely to the left of it. And there we've got it, 4.309. Okay, so I would say f changes from increasing to decreasing at x equals, what's that, 4.309. Okay, and that's all they asked for that one. That was nice. Determine the intervals on which the function g of x equals x squared times x minus 5 is decreasing. All right, so we're going to look at this one on the standard window as well. decreasing, but I can't see the location of the relative minimum. I can see it starts decreasing here, but I can't see where it's going to go to. And so I'm going to need to adjust my window. I think we could probably zoom out. That might work, but I'm thinking I might, adjust the window because I don't need all this negative x space. I might say x running from -2 to the same 10. But y, I'm going to let that run from, maybe -25 up to 5. So that's what I really need is the location of the minimum. Yeah, there we go. Right. And, I always think it's kind of best to overshoot and, have too big of a window and then zoom back in rather than having to adjust the window twice. So that's why I'm going to go, why I went to -25 is I didn't want to not go far enough. So I'm going to calculate the location of this minimum. That's going to be x equals 3.333. That's going to be 10/3. Okay, that little 5-7 there, that's some sort of round-off error with the calculator. X equals 3.333 is the kind of the right edge of the interval in which this function is decreasing. So I'm going to say x is between 0 to and 3.333. Okay, now if you wanted to say those were strictly less than inequalities, it would mean the same thing. Just depends on your definition of increase and decrease. To our definition of increase and decrease, technically this is the right answer, but nobody's ever going to hassle you about whether you use strict or non-strict inequalities, at least not in Algebra 2 or in any high school math class. So let p be the polynomial function here. Find the values of x that make p less than 0. Okay, first thing, I just want to remind you, f of x, p of x, whatever it is, that really means y. Okay, so we're going to look on the graph and see where y is less than 0. So, on an xy plane, y is less than 0 down here. So we're going to be interested in when the graph goes down in this lower half of the plane. So, and I'm going to even draw a little diagram. So, x to the 4 minus x squared minus 2. I feel like we have the algebraic tools to determine when this thing's positive and negative, but, we've got a calculator here, so why not? Oh, maybe not. Okay, it must be something else going on here. Oh, yeah. I actually think we do have the algebraic tools. I think it's going to be root 2 and negative root 2, but yeah. And then there's also 2 imaginary roots in there. I can see how that's because this thing is factorable. I think it's going to be x squared minus 2 and x squared plus 1. And we can go from there, and you know how that goes. We spent enough time solving these by hand. So I'm going to zoom back to the standard window. Okay, zoom 6, and then I'm going to calculate a 0. Okay, this thing looks pretty symmetric, so I'm more or less certain that, the other one's going to be positive 1.414, which, yeah, that's square root of 2, I think. What's it, 414. And then I can tell because it's only even powers of x, this is going to be an even function. We haven't really talked about even and odd functions, but it has symmetry across the y-axis, so I know this is going to be the positive version of 1.414. Yeah, there we go. Okay, and then this thing, okay, if we're interested in where y is less than 0, we're liking this portion of graph, and that's where x is between these two values. Okay, so but p is less than 0. Okay, p is equal to 0 at these places. So it's only less than 0 between the two places, and I'm just going to make that a strict inequality. So that's negative 1.414 less than x less than 1.414. All right, next it's going to ask us about the absolute minimum value of h. Okay, and I just really want to emphasize that this is what they're asking for, a value of h. Okay, so that means we're looking for the y value. Absolute minimum means of the very lowest point. Okay, so we're going to graph it, look and see if we can find like some absolute minimum. It's going to have to be an even degree polynomial, right? Because all even degree polynomials, they Yeah, I mean, if they open up, I suppose, if they're even and have a positive leading coefficient, they'll have some sort of absolute minimum somewhere. So, negative x times x plus 1 times x minus 2 times x minus 4. You know, and I think this would be a good time for me to point out that one of the weird things about the TI-84 is that this minus is different from that minus, and this minus is like for a negative number, whereas this one is for subtraction. So had you typed it in with subtract x, I think it would kick an error, and I just wouldn't want you to be confused why like you're typing it in the exact same way I did. For some reason it distinguishes between the two, even though we don't. Okay, so I've got this thing. I'm going to graph it on the standard window, and okay, I didn't even read that clearly. It said absolute maximum. It's not going to be the lowest point. It's going to be the very highest point, yeah. Hold on. Okay, I can see it's going to be over here. But I can't really see the top, so I'm going to need to adjust the window. I think I might let y run to 15. I hope that's enough. Yeah, that is going to be enough. And I just need to find the y coordinate of that point right there. So I'm going to calculate a maximum. Looks like it's between x equals 2 and x equals 4. Okay, and the x coordinate at which the absolute maximum occurred is 3.254. And you might be interested in the location of an absolute maximum, like in calculus, if you were interested in the time at which some maximum occurred, when there was the greatest amount of water in a tank or people in an auditorium or something. But you also might be interested in the actual amount that was the maximum, and in that case, that would be that 12.949. 12.949 is the maximum value of h of x over any real number that you can plug in for x. The maximum value you're going to get is 12.949. All right. Now we've got one here where we're looking at a graph, so I'm not sure we're going to need the calculator. Yeah, I don't think that's needed. What's the degree of f? Okay, well, I've got 1, 2, 3, 4, 5 x's that I'm counting, and it does look like I see 4 turning points, so yeah, okay, I'm seeing degree 5 here. Okay, 4 turning points means at least degree 5, but it would make sense. If we were 3 and we had 4 turning points, we thought it was degree 4, and we had 4 turning points, that would be a bad sign. Okay, the leading coefficient of f would be, if I was to expand this all out, which I'm not going to, and it's going to be 1/8 because of that division by 8. But it does make sense. I see an odd degree polynomial with positive leading coefficient based on the end behaviors here. If f has a relative maximum at x equals a, and a is a negative number, then a is what? Okay, that's where we're going to need to use the calculator, because that's what we're talking about. Okay. Yeah, and then we're going to need the locations of all the extrema here to answer the later questions. When is f increasing, and when is f greater than 3? Oh, I definitely like that problem. That's good. I'm glad I put that on there. I'd forgotten. Yeah, recording this before I delivered the lesson, so I remembered that we need to do some sort of intersect as well. We've just been calculating zeros. Anyway, all right, let's type this thing in. Get a fraction bar. Again, okay, I didn't show you. Reminding you again, we access the fraction bar by going to F1, which we have to click on the green key to access that F1, because that F1's in green. And we're going to type in our function, just as we're seeing it, x times x plus 1 times x minus 2 squared times x minus 4, all divided by 8. All right, and then we're going to graph this on the standard window. I actually end up wanting to zoom in. Yeah, I just pressed zoom and then 2 for zoom in. And I'm just going to zoom in around the origin, and I'm going to hope for the best. That is way too zoomed in. Yeah, okay, that was a risk. That's why I recommend just adjusting the window to what you can see. I'm going to just do it exactly like I see here. -2 to 5 in x. That would have been smarter. -2 up to 5. And y, I'm going to let it run from -3 up to 5. And that should give me the same picture I'm looking at here, right? Okay, great. So now I'm going to calculate the location of the maximum. Scrolling to the left of it, pressing enter, scrolling to the right of it, pressing enter, giving it a guess, and I get negative 0.616. Okay, and on what intervals is f increasing? So I'm going to need to just find the locations of these. Okay, I know that, you couldn't even see that. I know that the maximum right here is at x equals 2 because it's a double root. I see it happening there. Okay, it's a maximum. I don't need that. I'm going to calculate this minimum here. And I get 0.749. And then that's x equals 2, so I just need that other minimum. I'm going to calculate a minimum between 3 and 4. Okay, that's going to be x equals 3.467. Okay. And then I'm going to use that to determine the intervals on which this function is increasing. So it'll be increasing before a. So I'm going to say x is less than negative 0.616. It's going to be from this minimum to that maximum. The function's increasing. So like that. And then the last portion would be after the last relative minimum. It starts increasing, and it will increase forever after that. So x is greater than 3.467. Okay. And now, for what values of x is f of x greater than 3? Okay, well, I'm going to just show you f of x is equal to 3 right here. Okay, right there where it hits y equals 3. It's going to be greater after that. But this is not happening at a grid intersection spot. So what I'm going to need to do is on the calculator, graph y equals 3 and see where they end. So I'm going to zoom back in on this. Okay, yep, that's... Okay, I'm going to just, in y2, graph a new function, just the line y equals 3. I graph that. I run them into each other. Okay, I see they're intersecting. So I need to calculate the intersect between the first curve is blue, the second curve is red. Now, if you're working with one that doesn't have color, you'll see the one that they're talking about, and it's y1 and y2 that you want to intersect. And if for some reason it was off, you choose which curve with up and down. Okay, but for our sake, we're probably only ever graphing 2 curves to intersect them, so I don't think that's going to be relevant. There's only one intersection, so the guess doesn't really matter. And there, I found it, 4.221. Okay, so if x is beyond 4.221, well, then I know that y is going to be greater than 3, and I'll know that f of x is greater than 3. So I'm going to say f of x equals 3 at x equals 4.221. Okay, f of x is greater than 3 when x is greater than 4.221. Okay, g is a 6th degree polynomial with a positive leading coefficient. Is it possible for g to have 3 local maxima? Okay, so let's see. 6th degree with a positive leading coefficient. Okay, I could have up to 5 turning points. Okay, I know this is kind of my end behavior, so this could be a little sloppy. 1, 2, 3, 4, 5. That would be the greatest number of turnarounds, right? The greatest number of extrema. And I'm seeing 1 here, 1 there. No, it can't have more than 2. I could see us potentially having 3 relative maxima if this was a negative leading coefficient, but for positive, that's not going to work. Okay, we got one more page. I'm hoping to knock this out before my class starts. Graph sketching practice with no calculator. Perfect, we can do that. Okay, x-intercepts. X equals 2. That's going to be a double root. Actually, and then x equals -1. That's going to be a single root. Okay, the y-intercept, well, that's just f of 0. So f of 0 is the negative of 0 minus 2 squared, and then 0 plus 1. So I've got the negative of 4 times 1 equals negative 4. The degree is going to be 2 x's and another x is degree 3. Leading coefficient will be negative 1. So odd degree polynomial within negative leading coefficient means the end behavior is as x approaches positive infinity, y approaches negative infinity. I mean, I didn't draw the diagram. It's like y equals negative x cubed. And as x approaches negative infinity, y approaches positive infinity. Sketching the graph, I've only got 2 roots. It's negative 1 and positive 2. Okay, I know the end behaviors. It starts from above. X equals negative 1 is a single root, so it's going to pass through confidently. And then x equals 2 is a double root, so it'll turn around and bounce there. We don't know if the location of the minimum is to the left or the right of the y-axis. We would need a calculator for that, as you've seen today. And so I'm just going to draw the y-axis right in there. That's probably not proportional either. Yeah, but that's going to be our sketch. And then, oh, also I'm going to label that as negative 4, since I knew that was going to be my y-intercept. All right, one more. So the x-intercepts are going to be x equals negative 1, which is a double root, x equals positive 1, and x equals positive 3, and those are both single roots. The y-intercept is going to be, all right, g of 0 is the negative of 0 plus 1 squared times 0 minus 1 times 0 minus 3. So this is going to be 1 times 3 times negative 1. That's going to be negative 3. Okay, this is a 1, 2, 3, 4th degree polynomial using 4 total powers of x. The leading coefficient, I think, is again going to be negative 1, because if I expand that all out, I just have some number. I'd have x to the 4th plus some other stuff, and then I would distribute in the negative, and that would be negative 1. All right, and then the end behavior, even degree negative leading coefficient, it's like negative x squared. As x approaches positive or negative infinity, y is going to approach negative infinity. And then as far as sketching the graph of g, well, I'm just going to start with the zeros. Negative 1, 1, and 3. Okay, the end behavior, I know it's got to come from below. Which one's the double root? X equals negative 1. So I'm going to come through, I'm going to bounce right here. Then these other two I'm going to pass through confidently. They're single roots, and then that fits the end behavior. I know I've got a good sketch. That's going to be all. And that's all for this homework. Thanks for watching.